communication over IPv6 from instances in your VPC to the Internet. At the same time, it also prevents resources on the Internet from initiating communication with your instance directly. An egress-only Internet gateway is stateful. It forwards traffic from the instances in the subnet to the Internet, and then sends the response back to the instances. To route traffic from instances in your private subnet to the Internet, you would need to add a route in the route table and point all Internet-bound IPv6 traffic to an egress-only Internet gateway. Amazon Virtual Private Cloud, VPC. Internet connectivity. An Internet gateway is horizontally scaled, redundant, and highly available by default. It allows communication between your VPC and the Internet. Internet Gateway supports both IPv4 and IPv6 traffic. To enable Internet access for instances in a VPC subnet, you must attach an Internet Gateway to your VPC, add a route to your subnet's route table, and point your route table to the Internet Gateway. Make sure your instances have public IPv4 address, IPv6 address, or elastic IP address. An elastic IP address is a static, public IPv4 address. Static means it does not change over time. You can rapidly move an elastic IP address from one instance or network interface to another. Lastly, ensure that your network access control lists, NACLs, and security groups allow the relevant traffic to flow to and from your instance. On the other hand, you need a NAT gateway in the public Internet to enable instances in a private subnet to connect to the Internet, but prevent the Internet from initiating connections with the instances. NAT stands for Network Address Translation. When traffic goes to the Internet, the source IPv4 address in the private subnet is translated to the NAT gateway. Amazon Virtual Private Cloud, VPC. Amazon Virtual Private Cloud, VPC Overview. Amazon Virtual Private Cloud, VPC Concepts. The following are some of the key concepts for VPCs. When you create a VPC, you must specify a range of private IP addresses for the VPC, in the form of a classless interdomain routing, CIDR block notation. The allowed CIDR block size is between a /16 and /28. For example, this IPv4 CIDR block, 10.0.0.0/16 notation, when you write this out in 32 bits binary, you get the following. The number followed the slash symbol, in this case, 16, means that the first 16 bits remains fixed. And you can vary the next 16 bits, providing you with a total of 65,536 IP address ranges. A CIDR block of 0.0.0.0/0 would allow access to any IP address. To the original primary CIDR block, you can assign additional private IP addresses, a secondary CIDR block, to expand your VPC. Private IP addresses are local addresses in your VPC. They are not reachable over the Internet. They are used for communication between the instances in your VPC. To connect to your instance over the Internet, you can assign a globally unique, public IPv4 address to your instance. On the other hand, IPv6 addresses are public and reachable over the Internet. When you create a VPC with CIDR block, such as 10.0.0.0/16, note that you will not have all 65,536 IP addresses. It is because 5 IP addresses are reserved by AWS for internal use. To create more than one subnet in your VPC, make sure that the CIDR blocks do not overlap. That's why we specify 10.0.10.0 and 10.0.20.0 for the two subnets. /24 indicates assigning 251 IP addresses for the subnet. When you create a VPC, it automatically has a main route table, by default. You can also create your custom route tables. A route table contains a set of rules, called routes, that are used to determine where network traffic is directed. Each route in a table specifies a destination and a target. This main route table shows a local route that enables communication for all resources within this VPC. Each subnet in your VPC must be associated with a route table. You use a public subnet for resources that must be connected to the Internet, and a private subnet for resources that won't be connected to the Internet. You can make a subnet a public subnet by adding a route in your subnet route table to an Internet gateway to support inbound and outbound access to the public Internet. On the other hand, private subnet does not have a route to an internet gateway in the subnet route table. Also note that, most architectures allocate significantly more IP addresses available for private subnets than for public subnets.
AWS Transit Gateway Overview. AWS Transit Gateway is a managed service that helps you connect your Amazon VPCs, AWS accounts, and on-premises networks through a central hub. As you expand globally, inter-region peering connects transit gateways together using the AWS Global Network. Your data is automatically encrypted and never travels over the public internet. Because of its central position, AWS Transit Gateway Network Manager has a unique view over your entire network, even connecting to software-defined wide area network, or SD-WAN devices. Here are some key benefits. Centralized network management. Transit Gateway simplifies network management by providing a single entry point for all connected resources, eliminating the need to manage multiple VPCs and on-premises networks separately. High scalability. Transit Gateway can handle millions of routes and support up to 5,000 VPCs and on-premises networks per Transit Gateway, making it ideal for customers with large and complex network environments. Cost-effective. Customers pay only for the resources they use, making it a cost-effective solution for networking needs. It also removes the need to purchase and manage expensive hardware, such as routers and switches, saving customers money on upfront costs and maintenance. Here are some key features. Security. AWS Transit Gateway integrates with Identity and Access Management, IAM, and enables you to manage access to AWS Transit Gateway securely. Using IAM, you can create and manage AWS users and groups, and use permissions to deny and allow their access to the AWS Transit Gateway. Routing. AWS Transit Gateway supports dynamic and static Layer 3 routing between Amazon VPCs and a VPN. Routes determine the next hop, depending on the destination IP address of the packet, and can point to an Amazon VPC or to a VPN connection. SD-WAN compatibility. Compatible SD-WAN partners of AWS, such as Cisco, Aruba, Silver Peak, Aviatrix, and Versa have pre-configured AWS site-to-site VPNs so that SD-WAN solutions can automate the connection of your remote sites with AWS. With AWS Transit Gateway Network Manager, you get a unified view of your network across AWS and on-premises networks.